From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. All right, everybody, thanks for joining us today. We're really excited to be back on the air, and this time I have the co-host of the Fragmented podcast with us back again, Kaushik. Welcome back to the show.
Hey, it's good to be back this 2020.
How are you doing in 2020?
So far, so good. I had a very interesting flight that I just got because I spent some time with the folks and I came back and I got delayed and postponed and but I'm just happy to be home and in front of the mic so I can get to talk to you.
Well, it's good to have you back on. But even more importantly, a while back, you had scheduled today's recording with some very interesting individuals regarding a topic that's very highly requested. Would you mind telling the listeners what that topic is?
For sure. So listeners know that we've, at least on Fragmented, we've done good justice for the topic RX Java. But obviously with a lot of the new things that's coming in with coroutines in Kotlin, we actually haven't done an episode. And what we were doing was we were trying to wait for the perfect guests to come and help us understand more about coroutines, and we think we found the perfect guests today. The other thing is we also wanted coroutines to mature a little because when it was announced, there were a lot of things that weren't exactly there to compare with RX Java, and I think that has changed a little. Again, I haven't used coroutines as much, and I think Donn, you also haven't used it as much.
No.
But nevertheless, it has, I think, reached a point where it at least is fair to bring it up as a comparison. So in today's show, what we want to do is basically learn all about there is to coroutines and basically understand it from the point of view of, hey, what is this coroutines thing? If I already know RX Java, how does it compare? And for that, we have two amazing guests, and we'll let them introduce themselves. Welcome to the show, Manuel and Sean.
Hey
there,
great to be here.
I'm Manuel.
Hey guys, for the folks that aren't familiar with your background or what you do in the community or just even what you do at your job, could you both give your full name, where you work, and kind of your role and so forth?
Sure. Hi, I'm Sean McQuillan. I'm a developer advocate at Google, and I work with the Android team, and I spend a lot of time thinking about and talking about coroutines on Android.
Perfect.
Thank you.
Manuel?
Yeah, I'm Manuel Vivo. I'm actually part of the same team, Android engineer in the Google Developer Relations team, and actually focused on Android, Kotlin and coroutines, dependency injection, and Jetpack Compose. But today we're going to talk about coroutines.
Ooh, that's exciting. So before we even start, I had a couple of quick questions around this. So it's clear that Google sees coroutines as a viable solution, right? So much so that you're thinking of it almost in terms of, I know JetBrains is leading the effort in terms of what coroutines is, but Google is seriously considering this as a viable, I'm going to say concurrency, but I know it's not exactly concurrency, it's non-blocking, et cetera, but coroutines is being seen as a viable solution, right? Mm-hmm. Can you guys talk a little more towards that? Why do you think coroutines make sense now? Why does Google think it makes sense now, et cetera? And there are maybe many comparative solutions. Why coroutines from all of this? Could you throw a little light on that?
Yeah, I can start with that a little bit. So I think coroutines are really, really interesting for a couple of reasons. One, they're kind of a little bit easier to get started with than some of the other alternatives. And this is true in kind of every language. We see when coroutines get introduced to a language, they kind of really, really solve this kind of one-shot use case, or in RX terms, the single completable use case, really, really succinctly with really, really simple code. And then they also provide a nice language primitive to grow upon from there and build more complex things as you want to. So we can see already that Flow has been introduced, which is a more advanced API built on top of the primitive of coroutines. The other thing that's really, really interesting about coroutines is just the resounding success they've had in multiple programming language. So they've been successful in C#, Python, JavaScript now, and now they're being successful in Kotlin as well. So there's a lot of evidence that this is something that is easy for developers to get started with, and then it also scales as well.
And I don't know if folks even caught that, but like when you mentioned coroutines, the thing that many people don't realize, especially because like a lot of us are Android developers and like our entire careers have been in Android development, coroutines isn't exactly something that's new to Kotlin, right? This wasn't like an invention that came from Kotlin per se. It's this generic concept that exists in programming that the folks at JetBrains have chosen to sort of implement and use. So it's almost like an implementation of a sort of standard, right?
Yeah, you could think of it that way. There's some new stuff in the JetBrains implementation. So the suspend functions look a little bit different than other languages. And I quite like what JetBrains has done in Kotlin.
Yeah, that's pretty cool. Before we move to the next thing, can we also quickly touch on, because, we primarily were like an Android development show. So a lot of the Android developers who are like on the show might like also associate more. Can you guys tell like specifically your association with Android? Like, are you looking at using coroutines primarily in the Android side?
Yeah, I can start working on that. For example, like we recently added coroutines to the Android Developer Summit application. So, and then, refactoring the app that used to use live data just to manage from the repo layer down in our application. And, the live data wasn't actually made for that. So we found that, added a little bit of, complicated code. It wasn't actually made for that. So working with that at the level was very complicated. We can see how coroutines actually improve the code base a lot.
I mean, that's amazing that actually like following up on that. So live data was primarily down like more from the path of like, it was a very specific solution, right? But it sounds like coroutines is a little more generic, and you're still saying that with coroutines, it actually ends up being simpler. Is that a fair sort of summary?
Yeah. So, yeah, I would say that if we think of live data, it was made just for reactiveness between the view layer and the view model layer. When you put it away from that layer, things get complicated. And so now we can see coroutines as a viable solution for kind of all layers of your hierarchy. And actually, that was a great improvement for every code base, to be honest.
That's pretty cool.
So we've just kind of mentioned coroutines, but at this point, we do have a lot of listeners that are listening that have probably never even touched coroutines and are maybe just kind of even getting started with Kotlin. I'm wondering if you folks one of you could break down, in a real simple terms, like what are coroutines and why would a developer want to use them?
So I'll say that like the first thing to kind of like think about when I think about like what are coroutines, is there a language level syntax, kind of a Kotlin language level syntax for expressing a callback without having to kind of nest my code. So what that really means is like I can do something like make a network request, and then very typically, if I use basically everything but coroutines, I'm gonna have to do some level of nesting and put like a lambda in there. With coroutines, I can kind of flatten that and make it so that that callback is actually the result of the function. And the way coroutines does that is by introducing this thing called suspend and resume, as well as the normal function behavior. So when I do call that network request, it will suspend the function that called the network request. And then when the result is ready, it resumes that function. So kind of like it makes functions even more powerful to allow asynchronous behavior to be expressed inside of functions without having to introduce callbacks.
So if I were to break this down a little bit further, to summarize it, it's almost, from what I'm gathering, it seems like using coroutines, I can write my code in a way that looks very procedural, but actually suspends, kind of like almost pauses to go do the work, in another thread or whatever. I'm not sure how it works yet. And then when it's done, it comes back and then it continues down that procedural, type of appearance. Would that be correct?
That's absolutely right, and that's that. Maybe it goes to another thread, maybe it doesn't. Is a kind of a key distinction of coroutines versus some other solutions. In coroutines, it doesn't necessarily have to go to another thread. A good example of this, Chris Baines put together some really cool coroutine-based animation code recently. So what that does is like suspend some coroutine on the main thread until an animation has completed. So that's like really nice because you get rid of that on completion callback and you just say, wait for completion, and it just resumes once the animation has completed. So there doesn't actually have to be threading involved for this coroutine mechanism to take place.
Oh, interesting. That's one thing that's always like interested me a lot about like coroutines. The focus, and I guess like that's also the biggest drive, right? Like the focus is because a lot of the asynchronous sort of paradigms that we've been using, especially like with solutions like RxJava, has gone like the pure functional route where you have like a lot of these calls work in like the functional sense, right?
Mm-hmm.
So the code obviously also has to be written in this way where you're chaining calls, etc. But with coroutines, and like at least that implementation of it, the idea was you just keep writing your code in a very imperative way. But the biggest draw, so to speak, was like the asynchronous or like the non-blockingness of the calls.
Mm-hmm.
Being able to do that in a way where you don't have to necessarily deal with it. You're just able to like have it all magically work.
Yeah, definitely.
Right?
Mm-hmm. So this is basically what the suspend modifier on a function does. It's just telling the compiler, hey, this code might suspend at some point. So you just do your magic under the hood and it will automatically do that callback-based functionality for you. So basically the compiler is going to write those callbacks for you without noticing.
I think that literally that definition where you used the animation explanation of what Chris Baines did, that really just kind of solidified at me for what the possibilities of coroutines are, because I've written a lot of animation code, and for whatever reason, I remember having all these callbacks, but that was a great explanation. So thank you for that.
There is another mental model that you can follow, and sometimes I think about coroutines as it's this runnable with superpowers. It's kind of like I want to run a block of code, and the benefits of coroutines versus a runnable, for example, that you can easily swap threads, and then you can execute certain parts in a different thread, and you can even like handle errors in a better way. It's like, okay, I want to run this piece of code and I want to run it in this way. And so you can use coroutines for that as well. And it doesn't even mean that you have to swap threads. It's just, I want to run this piece of code in this particular thread.
So that's very interesting, right? Like, given that we're in suspend now, right? I have a quick question. So I have this function that says like, foo or do something. And I throw in a suspend on top of the suspend keyword on this function, right? And it so happens where I have like my imperative code, I have like statement 1, statement 2. Statement 3 basically is calling this function, and then statement 4 exists, right? By default, if I just throw in the suspend keyword and I specify nothing else, right? What exactly happens there? Does that execute on the same thread? So is it as good as imperative until I explicitly specify a thread, or like am I just thinking about this thing incorrectly? Can you guys help me understand that bit?
Yeah.
So is this a suspend function that made no other suspend function calls? Was that?
Say that again. Sorry.
Was that you just made you put suspend on a function that was previously a regular function and no other changes?
Mm-hmm. Yes.
Yeah. So if you do that, it actually compiles down just to a regular function. So one of the things about coroutines is suspend functions and all this like this callback behavior. It basically only happens if you're calling another suspend function. So if you take a regular function and just drop a suspend modifier on it, it actually ends up generating the exact same function it would without that suspend modifier, because there's no calls to other suspend functions.
So that's a perfect, I think this is a perfect opportunity here to say, all right, can you walk us through, and I know I kind of jumping ahead here, but I'm trying to get a mental model from a developer perspective, especially around code, and seeing that this is audio, it's hard to explain code, but I think we kind of have to do it here. From if I'm developing an application and I want to use a coroutine, and I heard you say, one suspend function needs to call a different one. How would I implement this? Maybe, like you said, I need to make a network call to get some data. How would I use coroutines? Like, what would a simple function look like if I just fun function name? Where do I put the suspend? How do we build that as a developer in a very simple example, if possible?
So right now, the good things about coroutines is they are integrated in almost every library that you can imagine. Probably the top most used libraries like Retrofit or Room for database. So right now, Retrofit, if you want to make a network request, it already supports suspend functions. So whenever you create your interface with Retrofit, that function that goes off the network, it will be marked as a suspend function. So now if you have your repo layer and you have a function that, let's say, fed user, for example, that will make use of that suspend function from retrofit. As we said before, since that function in the repo layer calls another suspend function, that function needs to be marked as a suspend function as well. So that suspend function means that it needs to be called from a coroutine. And if we are thinking a typical Android architecture, you will start the coroutine in the view model layer. So if we think about the architecture, repo layer and the data sources or like service layers, they should be suspend functions all the way down. And then the view model will be in charge of, if needed, create that coroutine. That we haven't mentioned how to create a coroutine yet. But that could be the kind of the mental model to follow. And then in the view model, if you want to fetch that user, you can create a coroutine with launch, for example, just to trigger that computation. And so the view model will call the repo and will call fetch user, and you get the result back.
Okay, I want to remove even more complexity of this. So I'm going to challenge you guys a little bit here. Can we remove anything view model related, anything like that? Well, let's assume I am a beginner. I'm learning about coroutines. I have an activity. I'm inside of my activity, and on a button click, I want something to happen. I don't have view models yet. How would that work? And maybe we need to get into the actual implementation of the coroutine. I'm not sure. So I literally am approaching this from a complete beginner mindset. Walk me through it.
Yes. So if you want to remove the view model layer, that's fine. You have to go to the activity to trigger that function to the repo layer, right? To call fetch user. And one thing that we haven't mentioned until now, it's something called structured concurrency, which is kind of a paradigm that forces you to think about who is going to manage the life cycle of that computation. And in this case, we can think of the activity as the life cycle, our component that knows when that network request is no longer needed. And so for that, you have something called coroutine scope that is actually going to manage and can start coroutines, and it's going to manage the life cycle of those computations. So in Android, we provide some libraries that give you a life cycle scope. And with that, you triggered your coroutine, calling, for example, lifecycle scope.launch. And inside that coroutine, you can call now the repo layer, that suspend function. That the good thing about coroutine is that it will return just the full user object. So it doesn't return anything like RxJava as you might have a single or completable. It will return the actual user. And so now in your UI, you just can call, update user or something from the UI layer. And retrofit is going to be in charge of moving that network request off of the main thread.
The only thing I'd mention on that, and just this is in general when you think about how you structure your Android application, if you do launch your coroutine in the activity to make something like a network request, that is going to restart on rotation. So that's one of the reasons why you might want to consider adding a view model to your stack there.
Makes sense. Yeah, I agree with that. Now, if let's just say, and this is just for a learning perspective, if we're sticking with the simple activity, implementation, and then we can hop into the view model. How do I launch that coroutine? Is there a block of code that I need to write that tells me that I can launch a coroutine, or what does that look like? How do I have I have all these suspend functions, but I don't know. I can't put the glue together. I can't glue it all together. Like where am I kicking it off, and how do I do it?
So there's these things called coroutine builders, right? So they have these one we call launch, which is typically the one that you almost always use to start a new computation like this. There's also one called async, and what these are is they're functions that kind of use the coroutine's internals to create a new coroutine, which you can kind of mentally think of as a really lightweight thread. It's different than a thread, but it has a lot of similar properties. And then it starts that thread. So what you'll do is you'll say something like launch, and then you give it a lambda, and then it creates a new coroutine and then calls into the body of that lambda. So that's kind of like the code syntax for creating a new coroutine. And you can really map that to, like, mental model wise, to the same thing you do as when you create a new thread. And in order to kind of make sure we don't actually leak this new coroutine, which is kind of like, doing computation, and it's kind of like a thread, we'll use something called a coroutine scope that Manuel already mentioned. So a coroutine scope is literally all it's really responsible for is some configuration of where to launch the coroutine, as well as keeping track of all of the coroutines and all of their children that get launched inside of it. So that gives you the ability, if you use an activity scope, for example, or a lifecycle scope on an activity, to cancel all of the coroutines when the activity is destroyed, which is fantastic because it helps us avoid kind of memory leaks of the view layer on Android.
Got it. And by default, when you just say a launch, do you also have to provide the scope with the launch, or is there like a default scope, or does it like infer that scope from like where it is, etc.?
So to enforce that in the syntax layer, launch is an extension function on coroutine scope. So any object that implements coroutine scope has launch.
So how many different scopes are there? You said, is there a lifecycle scope that maybe I would use for Android if I was just kind of hacking something together for fun, or what?
Yeah, so in the libraries that we ship, we put together a lifecycle scope and a view model scope as public APIs. Okay. And then scopes are actually really cheap in coroutines. It's something that, like, when you first start out, I had this learning curve where I tried to avoid making them because they looked a little bit like executor services. So I was afraid they were holding threads and like all these big expensive things. And they turn out to actually be very, very cheap objects. They have 2 references. They're very cheap to construct. So we also construct some scopes inside of the live data builder that we don't give you publicly. We also construct some scopes inside of Room. And if you go dig into Retrofit, it constructs some scopes as well. So you can kind of think of scopes as these lightweight building blocks you should use whenever you want to create a new coroutine and kind of own its life cycle.
And so if this was like a Android lifecycle, I don't know the proper name for it. I'm just guessing it's like Android lifecycle scope. And then was there like a dot launch method that's the extension method on that? And I pass in a Lambda that calls into my suspend functions? Is that what that looks like?
Exactly, yes.
Yeah, that makes sense. So the imperative aspect of this, right? Like say we have this function that we're like doing the network request, right? The network request returns a response object, right? Honestly, it doesn't matter what the response is. Let's just say it's a network response. So when I'm looking at my activity code, I have like a bunch of statements. You say it's on my onStart method. Again, like listeners, don't worry too much about like clean code, etc. Now we're only trying to understand the fundamentals. So we're going to be doing some things here that don't really you shouldn't really be doing on a production code base. But just for the sake of clarity, right? So I have on my onStart, I have like a bunch of statements. I'm setting my toolbar, text view, all that is there. Okay, now I'm basically going to execute my network request, right? It's time to execute my network request. What I'm going to do is I'm going to use the launch, create the coroutine using the launch method. And because again, like we talked about this, the lifecycle extension, we have a library that ships with this. So we're just going to be using the launch. I'm going to be calling my view model.do network request inside this launch method. Again, I'm in the activity. And my do network request is a suspend function inside view model. It calls into retrofit. Retrofit, again, we're using the suspend keyword in retrofit. So it gives back a suspending function that comes down to the view model. The view model, the suspend function there returns a network response. That network response comes back to my activity. Now I'm going to use this network response. So I'm still within the launch code block inside the Lambda. I use this network response. I set it on a text view not exactly, but say I'm using this network response for now to do something. And then I proceed to the next statement that's outside the launch block, right? If that makes sense. How exactly does that play? Because this is now going to be non-blocking, right? So the stuff that I write, is this exactly like, say, because I've used RxJava, is this basically the same as like the code that I write after my subscribe call? The thing that I think I'm trying to like wrap my head around is with coroutines, you're basically writing imperative code and you operate with the result that comes back in an imperative fashion, right? In RxJava, that's clearly not what happens, right? Like you have the subscribe block and they're like, this is the callback, do what you want inside the subscribe block and then proceed to the next thing. But I don't think that's how it works with coroutines, right? Am I visualizing this right?
Yeah, you're totally right. So what happens there, like imagine in that launch you have, in the Lambda, you have 2 lines of code, one that calls the view model and the other one that updates your UI. And what is going to happen while the network request is being processed, that computation is going to be suspended. and only until the network request comes back, and after the network request being processed, then the UI will be updated. And the computation gets suspended and then gets resumed whenever the network request comes back.
Got it. And much like how, so say I have, okay, I'm going to say the network request comes back and I update text view A, right? So this is within the launch block. Now I'm outside the launch block, I'm after, and I update text view B, right? Now, if this was like Rx Java world, right? Like depending on how long the computation takes, text view B would get updated right away, right? And then when the network request is done, text view A would update. Is that the same that would happen here?
Yeah, definitely. Like when you call launch, it's like a side effect. Like something is going to be processed later. And then launch, when launch gets called, then the line after the launch will be called right after.
Got it.
One way to think about this is so that the way that the main coroutine dispatcher, which is the thing that actually is running these coroutines on the main thread here, works is it's going to call looper.post with that new coroutine.
Got it. Okay. Much like how like it's done with like the main loop and the other stuff that we have in Android.
Mm-hmm.
Cool. Okay. So I think at this point I've grappled with the idea of suspend, and I think I understand how this works. And you guys did a very good job of like sort of breaking down how to connect the dots. So it's not just throwing the suspend. There's all obviously like this backing sort of coroutine creation that has to happen for like this scope. You have to specify this scope, and that makes perfect sense because it's not just magical, right? Like unless you specify the scope, it's not going to know what to do. So I'm with you so far there. Donn, does suspend make sense to you so far?
Yeah, it does make sense to me so far. And the scope's kind of what, fires it off. So all that kind of makes sense. And the compiler's smart enough to know that if it's not called within another suspend function, it kind of treats it as a regular function. So that makes sense. One question I do have that we talked about earlier on was someone mentioned, concurrency versus non-blocking versus asynchronous. What is coroutines? Like, is it concurrency? Is it asynchronous? Is it non-blocking? Can you explain that in layman's terms for folks just getting started with coroutines? Or how does it support that model?
So all of the above. So all these words kind of fit in this space where like they all kind of mean like subtly and slightly different things. But I would really drive towards concurrency when talking about coroutines.
Okay.
And the example I give to kind of explain what concurrency is actually the main thread on Android, which has concurrency. So on the main thread, even though it's a single thread and it only does one thing at a time, right? Because it's a single thread. It's still capable of handling all your click events. And then in between those click events, it's capable of redrawing the screen a bunch of times and setting a text view, handling another click event. And the way it does that is it kind of jumps between all of these different little tasks. You can kind of think of them as like little micro tasks. Hopefully, they're all small tasks, so you don't block the main thread. So what that means is like I handle a click event, and then maybe that sets a text view, and then maybe that redraws the screen. And all of these are little small things that the main thread is doing. And then the main thread becomes, idle and just sits there waiting for another click event or another repaint event to come in. And by switching between all of these small things, the main thread's actually able to do a whole lot of things on a single thread. And I call this model concurrency. And this term is, I didn't make that term up. That's what a common term of concurrency. And coroutines kind of do that exact same thing. So we keep talking about these coroutines that are launched on the main thread in this call here. And in all of these situations, if you execute more suspend functions on the main thread, it's going to kind of hop between these small little units of work on the main thread.
I like that. A common thing, when I used to try to understand concurrency, like for folks who've seen like Matrix, the movie, there's this scene where like Neo is dodging bullets, right? And I'm going a little philosophical here, but basically when you look at the scene, it looks, well, actually it's first Agent Smith who like does the bullet dodging, right? And then like Neo tries to like emulate the same thing. When you look at it, it looks like, oh my God, like, he's splitting himself and like dodging the bullets in multiple ways. You really have to look at the scene to make sense.
Yeah.
But what's really happening is like, it's just happening so fast and it's like switching like every individual action that your eyes trick you into thinking that like it's all happening, uniformly, right? So it's the same thing with concurrency. Like you have a lot of these things that look like they're happening simultaneously, but that's only because they're like small units and these small units of work happen really fast and like, at different intervals when they're ready to be executed. So
I would expand upon that just since this might be someone's first introduction to the Kotlin X Coroutines API surface. The coroutines that ship with Kotlin X Coroutines also allow you to switch threads. So we haven't talked about this yet, but this is how when you call all the way down to room or room specifically, when you call all the way down to room and it wants to work on the background thread for a little bit, what that API looks like kind of at the application level is with context, and you can pass it a dispatcher, which is the way you tell coroutines what thread you want to run on. So inside the body of any coroutine, I can say with context and say like dispatchers.io and get access to a thread pool that's optimized for IO dispatch.
Right. And that's basically how you open up the concurrency. Like that's where like you can start doing like multi-threading pretty easily, right? Like if you say, hey, I want this to happen in the IO, I want like something else to happen in the network computation. I wrote a blog post about this sometime, and this was inspired by Eric Hellman, like who talks about this. Typically the thing initially for developers starting out, they might ask like, why even bother with all these threads, right? Like there's just the main thread and everything else. Why can't we just like live a simple world where we just have the main thread and everything else and nothing else, right? The reason is, and again, you can go to the blog post and like it talks about some of these details, but you don't want the same kind of work always. Like there is this idea of when things become idle, and I'm not going to go into the details there, but there is a lot of benefit into specifying threads and having work be done on like specific threads, right? So there is like definitely value in that. And so it's nice to know that Coroutines also allows this. And this is where like the whole dispatchers thing comes in, right? And dispatchers are basically like, again, like for me, everything I look at is I'm going to try and see how I can compare it with like the RxJava model. This is basically like my schedulers, right?
Yeah, it's an exact parallel.
Yeah, to expand a little bit on that, I would say like when you have a suspend function, it just executes as a regular function in the sense that only when everything that suspended function started, only after everything finishes, then it will return. So even if you have a with context that swaps to a different thread, it is going to wait for that computation in that thread to finish before returning the function. So that means that it reads as a regular code, right? Even if you do asynchronous operations on a different thread.
Got it. I remember, I think there's this person who goes by the name Venkat Subramaniam, and
it's great.
He gave a talk on coroutines, actually. I think it was 2017 or 2018, one of the Kotlin confs. And he talks about this, right? Like, I think he breaks down into like this context thing. We keep using it in the generic sense of the word, but like it actually has a lot of meaning, right? If you think about it, like it isn't magic. Like in the end, the way that you're talking between these two, between like multiple threads, it has to happen somehow, right? And like it has to happen gracefully. And like the way this happens is like using like this model of contexts, right? And that's the thing that Manuel also mentioned. And again, I'm not going to go into too much details also because that is like, that's worth just looking into. But it makes a lot of sense to me now hearing Manuel and Sean say these things because I understand like, that context has to switch between the threads. And so basically what coroutines, the implementation, if someone at some point dove in to like the actual implementation of coroutines, you will notice this thing where like these contexts are being handled, right? Like we don't have to do that. And that's the beauty of using these libraries, but to gracefully move between these threads, that has to happen. All right. So I know we touched on a little about like the RX comparison stuff. I wanted to bring this in because like when I looked at coroutines initially, that was like the biggest problem for me, right? Because coroutines is maturing right now, I see a lot of terms being thrown, right? I have suspend functions, I have flows, I have channels, I have like coroutines, I have dispatchers. Can one of you guys like help me understand how this compares? Like, like when people say flow, when they say channel, when they say coroutines, when they say suspend functions, what do they mean?
Yeah. So for example, I can start, then Sean can follow up. So basically, whenever you have a suspend function, it's kind of a one-shot request that usually maps to this, like RxJava may be single or completable. But the good thing is that you don't need those constructs. You don't need those words. You just have a suspend function and the return type. So a completable might be a suspend function returning unit. And single might be returning an actual, object, like for example, user, as we mentioned before. And then maybe you can replace it with a nullable user that may return a user or may not. And then if we start talking about flow and channel, flow is basically like an observable. It's a called observable that every time that you subscribe to it, it's going to start executing its block of code. And then channel, kind of in a high level, probably Sean can talk more about this, that as a channel, as a primitive. But then you also have this broadcast channel, and an event sent to this broadcast channel can be received by multiple observers. That is kind of what you might have in a subject, for example, a processor in RxJava.
The thing about channel is it's a large API that covers a whole bunch of different things. So channel means like 4 different things, but they all kind of implement the same core API. So I often think about channels as a blocking queue. So this is kind of a really old design pattern I think it's in the Java language libraries, where basically you can offer things to this blocking queue, and if there's space available, it will go ahead and put that on a queue. And if there's not, it will suspend the caller that's trying to offer something to the queue. And then similarly, there's a consumer side as well. And so these are really, really useful for coordinating between two different coroutines that want to kind of share data, but they don't want to actually end up running in lockstep with each other. So this is helpful when you have like large independent processes, like maybe you would have with down inside of room. It wants to keep track of whether a table has been updated. So it's going to represent that with a channel, but then it wants to expose that as just regular suspend function returns. I know channel gets a little bit fuzzy. I think the core there is it's a low level concurrency primitive, and if you use it as such, I think it works pretty well.
Interesting. Initially, my thought process was like channels are like the hot equivalent. So like, for Rx, it's like connectable observables, right? But I'm like, from what you said, it looks like it's a little more. It's not just as simple as that paradigm. Like there's it while the API is the same, like it sounds like you can like start to do more stuff.
Yeah, so you can use it for that. For example, like as I said, you can use the broadcast channel to broadcast some information to different observers, and that kind of maps to the subject or like observable in RxJava.
Ah, I see. Okay, so broadcast channel.
Or the connectable observable. Yeah, the broadcast channel.
All right, so I'm gonna resort back and be my typical village idiot self here, and I have the suspend keyword, which we have talked about before. Like we kind of covered that in detail to kind of set up our coroutine and fire it off. But now we're talking about something called a channel, and that has nothing to do with the suspend keyword, from what I understand. And then we have something called flow too. I guess my real question is like, if I have the suspend keyword and I can suspend things, why would I use something like a channel or a flow? What's the real use case for a developer to kind of use either one of those? I'm not putting the dots together here.
As I said before, for example, like the suspend keyword, you would use it for one-shot operations. When you want to start getting a stream of data, that's when you might have to use either flow or a channel. Because, flow is streaming of data kind of as you might have with an observable in RxJava. And so if it's one-shot request, then go for a suspend function. If you want to continuously receive different items, then go for these constructs.
Okay, so maybe if I'm building like a chat app or I'm keeping track of just user input events or something like that, it could be a constant stream of data, then if flow or channel would make sense. But if it's just, hey, go get me the list of customers, that might be a good use of suspend.
Yeah.
I actually like that question a lot, because then it moves, okay, so if I had like a one-shot thing, suspend, then if I have a streamed thing, then I would go either with flow or channel. Can I get away with just using flow, or like is there also like a very specific use case for channel? Can one of you guys touch on that aspect as well? Like when do I start thinking about channels, or can I just live life predominantly as an Android developer with flow? And also like, if I'm writing like this background like Kotlin server, can I just, when should I start thinking about channels, or can I just try to stick with flow?
the way I think about it is to typically prefer Flow as your public API. And I mean that kind of like in a very loose sense for public API. But if I have like a repository or some class that's trying to expose a streaming sequence of data over to another class, I'm typically going to want to expose Flow as the public API there. It's a little bit simpler to interact with the Flow, both from the consumption side as well as just the actual the model that it provides you is just a little bit easier to work with as a consumer. Channels, again, they're kind of closer to this kind of blocking queue. So you're setting up kind of blocking queue workers and building like concurrency primitives out of them. So it's as a public API, they tend to be a little bit more complex and bring a little bit more mental model with them. So I tend to prefer Flow almost all the time when I'm exposing something. Inside of a function or a class, very often I will need a channel because it's like a very convenient way to communicate between two unrelated processes. And I might end up with those if, say, for example, I have a suspend function that got called by the user and a flow that I'm observing. So let me give like a concrete example of this. Let's say I'm trying to implement a search of a screen. So I have like a whole bunch of names on the screen. The user can type into a text box, and I want to filter the names that are there. So I might make a channel that holds the current text box input. So that's going to be kind of this blocking queue. It's a way that I can get values between two coroutines. And then I'm going to have a flow that's just the list of names, and then it's going to also observe that channel, and it's going to put out the combined results. So that's kind of how you can think about that. The channel is kind of this primitive building block for building kind of these concurrency things, and flow is like a really good way to actually consume this from another class.
So can you where's the channel at in that example again, and what is it doing?
Mm-hmm.
To reiterate.
Yeah. So that's so there's a channel in there that basically allows for when you get this on text change callback, you can offer the new text to that channel, and that'll allow then the flow to sit there observing that channel to pull the text values out. And you want to do that because you have to have some way to synchronize between possibly different threads, but definitely different coroutines. And channels provide exactly that primitive.
This is me resorting back to my RX stuff. But to me, it seems like, couldn't I just use two flows to do that?
There's no... so Flow doesn't provide any way to send a value to it from outside of the flow. And so that's one of the reasons you go for channel in this situation. It would be possible with that API. And there's some discussions in some of the experimental side of Flow about adding APIs similar to that.
Okay.
I guess like in the RX land, and again, you guys can correct me if I'm wrong, we have RX bindings or libraries that basically transform the text input into observables or like the equivalent of flows.
Yeah.
So if we did have that library, then we again, this is me. I don't know coroutines as well to like predict this, but in that case, we could probably operate with two flows. But given that doesn't exist, you need a way to sort of like send the input into an observable, like in quotes. And typically the way we would do this is like with subjects or something in RX, right? So in coroutines, because we need to send this input into the stream, I'm guessing we use a channel there. Is like that a fair sort of comparison?
Mm-hmm. Yeah, I think something we are missing here is the fact that Flow, it's still in experimental. So the base Flow API is stable, but there are some operators that are still experimental. And actually there is some pieces that are still missing. And there are some use cases where nowadays you would use a channel, because that functionality is not available right now in Flow. But Flow is iterating, and there are some future improvements that are gonna, all those cases where right now you would use a channel, you would instead in the future use just the Flow API.
Interesting. Given that you've touched on this, like maybe we should talk about this too, in terms of like, because that's one thing that both Donn and I we've been waiting to talk about coroutines just because we want to understand, like, we don't want this experimental thing and talk about it and then have it change completely. What is the status of like the maturity of like coroutines in general, right? Like what if these APIs, say I'm a developer today and I want to use some of these constructs, how confidently can I use some of these things, and what about these things are changing?
Yeah, so as I said before, like everything works pretty well. As in we are using we used it in production for the Android Developer Summit application. And it is true, as I was saying, probably you cannot use the full flesh out ideal Flow API that you might have in the future, but then you can kind of imitate that behavior with a channel right now. So channels as the core primitive are stable, and the basics or like the core Flow APIs are also stable. And there are some operators like filter, map, on each. All those operators are also stable, but there are some others that are experimental. So you have like merge as an experimental, transform, latest. Like, there are some operators that are experimental and that are subject to change in the future.
Interesting.
So the suspend mechanism you have the suspend keyword you're adding to functions. So that, and as well as all of the kind of job support, all of the parts of Kotlin X coroutines related to one-shot operations are now very stable and have been stable for several months now.
Okay.
And then the flow and channel, both of those, as Manuel said, have experimental areas that you're going to end up touching in production application usage that hopefully over the course of this year will end up more stable. Hopefully we can hit like a fully stable Linux coroutines by the end of the year, but we'll see how that goes. So if you're someone that's like really not interested in adopting experimental technologies, maybe wait a little bit longer for that to stabilize. But it does all work right now. And it's mostly the APIs may be changing. And there may be a couple larger changes coming in Flow because as we get more feedback about how the libraries are used.
That's good to know. That's like, I think that you've summarized that also like pretty well. Because in the end, that's what matters, right? Like we don't want developers listening to this thinking, oh my God, this is ready. Let's just do this, like my production application, and then realize, actually, things are changing constantly and I didn't expect that. So that's really good to know. Thank you.
Now, one of the things that we're really big here on the podcast, and Kaushik and I both are big proponents of, is testing. So what does the testing surface area look like in regards to coroutines? So if I'm doing something that maybe uses different dispatchers for, perhaps different types of threads and concurrency, how do I test these things when I'm using, or how do I test when I'm using coroutines? Are there tools, is there libraries, or can I just kind of provide different implementations, or what's your guidance there?
So there's a library, Kotlin X coroutines test, that I've helped contribute to, so I can talk a bit about this. So basically, the core idea with coroutines is in production you might have multiple threads, but if you're testing kind of complex concurrency situations where you want to create like these complicated happens before relationships, that's where you say this block of code runs before this other block of code, and you might do this if you want to create interesting like maybe possible deadlocks or something like that, and this happens in complex concurrency situations. Then there's this library called Kotlin X coroutines test, and it provides you a test dispatcher. And the idea there is you swap out all of the dispatchers that your coroutines were using that previously had provided multiple threads, like the main thread or the IO thread pool, for this, and then they all end up running on a single thread, and then you can end up with really fine-grained control over their execution and kind of help reproduce sort of complex concurrency situations. So that comes with test coroutine dispatcher, as well as test coroutine scope. And that's very similar to the test scheduler in RX in that it allows you to control time, as well as it makes some attempts to make sure that you don't launch coroutines in your test that leak after the end of the test. And it does that using another function called run blocking test, which is similar to launch. It's one of these coroutine builders, but it's specifically going to block the test thread until all of the coroutines it launches completes, or it'll throw an exception if it fails.
Now, let me make sure I got this right. Do I use that run blocking test? Do I use it in my actual Android app, or is that only part of my test code? Where does that go?
That's part of your test code, right? So that there's this thing you want to do to kind of like motivate why it exists. So you're in like a JUnit test and you're inside the test body. What you don't want to do is kind of launch an asynchronous coroutine and then like immediately finish the test body, because then it can't fail, right? Because the test is already completed from JUnit's perspective. So what you need to do is block the test thread, and run blocking will launch a coroutine and then block the current thread until that coroutine completes. So that gives you that what you want.
Oh, okay. So it's that makes sense. So you're just basically telling, hey, JUnit, we got some coroutine stuff here. Why don't you go ahead and wait until we get done here?
Mm-hmm. Exactly.
Now, how does this? What about in regards to testing with like Espresso or anything like that? Because sometimes I know Espresso had idling resource problems with RX, and we had to tell Espresso, hey, you need to slow down and wait for RX to get done. Do we have any of those similar problems with coroutines?
I know there's like been like idling resources and stuff. Is there like work being done? Like, do you folks know? I mean, if not, it's fine. We can always.
Yeah, so there's no libraries that implement an idling resource. And this one's a little bit interesting with coroutines because it's not exactly clear what a universal idling resource with coroutines looks like. We've kind of been talking about coroutines, these one-shot suspend functions, the entire podcast. But it's totally valid to write like a little infinite loop coroutine that just sits there spinning forever, doing a little bit of work and delaying for a while. So the existence of a suspended coroutine isn't enough to say that the UI should be suspended. So there's a couple different examples. There's a open issue on the Kotlin coroutines tracker. There's been a couple correct idling resources that people have published in that thread, but none of them have made it up to the point that they're in a library.
Yeah, I think that the solution that we are using right now is because of that. Is that usually we tell, for example, if you use dependency injection in your application, the good practice here is kind of inject your dispatcher where you want to run your coding. And so here what we do is create kind of a dispatchers provider, and we hook those. We create a special dispatcher and we hook in with the async tasks thread pool. And so Espresso automatically will recognize that there is some work happening in the async task thread. And we are just tweaking, a couple of functions just to tweak and say, now all your coroutines are going to be executed in this particular thread that Espresso is going to pick up and know when you are doing some work.
Oh, okay. Okay. And that's going to be, is that inside of the issue tracker on the Kotlin X coroutines test stuff?
I think that one's on Kotlin X coroutines.
It's
all the same repository now that I think about it.
Okay. All right, cool. Yeah, I just want to add a link to the show notes for folks that are interested and want to kind of dig in deeper.
Something you can do as well is that in RxJava, you can replace the schedulers with the ones you want. And right now in coroutines, you can only overwrite the main dispatcher. But I think in the future, they are considering expanding this to the other dispatchers that you might have.
Yeah, that'd be interesting to see how that pans out.
Yeah. So testing was one topic. The other one that I know was also contested, or that's like the one where we have a lot of problems. So it's interesting to see how coroutines would like solve this, at least like in the Rx days, right? Error handling was always this issue, right? How like there are two aspects of it. One is like how do you handle errors that that get surfaced, and the other, more importantly, is like if something goes wrong, how do you like debug that stack trace, right? Because that's like been very tricky with Rx. At least it was in the early days, and like there's been a lot of work that's done in Rx now to like make that a little more evident. But I even remember in some of the early days of RX1, like if you get a crash or something because something, you got an exception in like some like deeply nested composed of operator, like it's impossible to like kind of debug without like a lot of trouble, right? What does the state of error handling look like in coroutines?
Right now, the good things about coroutines that they are part of the language, right? You have all those constructs that are just native to Kotlin. And so you mainly use the error handling support in Kotlin. So you can imagine that you have a try catch and a few other functions that help you with error handling. And so, for example, like if a coroutine is going to throw an exception, then you can grab it inside a try catch. For example, let's say the suspend function can throw, you can grab it. But then there is something that we didn't mention in the show that is very important, which is the job of a coroutine. And you can think of the job of a coroutine as a subscription in RxJava, right? So the job is going to manage the life cycle of the coroutine. And if we think about these jobs, we said before that coroutines can create more coroutines. This is going to create a kind of task hierarchy in which coroutines are going to be executed in. So with a job, for example, you can cancel a coroutine. And for example, if a coroutine fails, that somehow is going to affect the hierarchy in which that coroutine is in. And so that failure is going to be propagated. And at some point in the hierarchy, you can try catch that specific coroutine, and then you can handle that particular exception. But what you get is the exception that it's being thrown. right? So if it, is something through an illegal state exception or something, you will get that specific exception.
Interesting. I was gonna ask, say I didn't have a try catch and my app crashed or something, and I go to Crashlytics or something or Firebase and see that my error is being reported. What you're saying is it would actually show where from where it got, because it's being propagated correctly. You would actually see the error shown up there.
Yeah.
Okay. It's good to know. I know we are running a little late. This is been super interesting. And we can go we can just keep going on for way longer, but we gotta Sean and Manuel go. So, but before we do that, we had a couple of quick sort of lightning round kind of questions that we just wanted to ask. Donn, you want to kick us off?
Yeah. So first one here is we've talked specifically about Android this entire conversation. So the big question is are coroutines for Android only?
I'll grab this. So no, specifically. In fact, actually, so I did coroutines on backend before I came to Android. And when Kotlin introduced coroutines, I was actually like, do these even make sense on Android? Because on backend, you typically use them as a kind of a performance optimization. So they're very, very popular with backend Kotlin developers for a lot of the same reasons they're popular with backend developers on other languages. I earlier in this podcast compared them kind of to threads. And they are very similar to threads, but they have a different memory characteristic than threads in that they use just substantially less memory than creating a new thread. So it's much easier to create a large number of them in a backend system. So they're commonly used in highly scaled backend systems.
But also you can use it for Kotlin multi-platform, right? I think they recently added support for that, and obviously they are going to increase the support for it in the future.
Interesting. Oh yeah. So that I guess that's another good question. Is it available for multi-platform? But you're saying that there's work being done to introduce it so that can just be used as a universal solution across anywhere that we can use Kotlin multi-platform. So iOS, backend, Android, presumably. Cool. Okay. So the next question is, when should I not use coroutines? Because here's the other, and I think the drive for this question is when people started off with RX, they would use RX for everything, right? In places that admittedly we shouldn't have been using RX, right? Can one of you guys take this? Manuel, maybe you. When do you think, is there an opportunity where you think actually, you know what, you shouldn't be using coroutines here, just don't complicate stuff?
Yeah, definitely. If you want a fully stable API, coroutines, extending it to Flow are not quite there yet. As in you want a fully supported solution. And you should not use it when it's not going to make your team more efficient. If your team is using RxJava and everyone understands it and you are happy with it, I don't see the benefit of swapping to coroutines, to be honest. Probably as a team, you have to discuss whether introducing a new technology or not is something that you should do. But if it's not going to make your life more productive or your team more productive, don't use it.
Another quick question I had, and maybe you guys can take this, is okay, which is better, RxJava or coroutines?
Wow.
They're all my favorite children.
I'm just kidding. I want to I like throwing a wrench sometimes into things and just seeing how things go. The thing, the RxJava, thank you for saying, the RxJava comparison is very interesting. I think what people don't realize is RxJava also, and Donn and I were actually talking about this some time back. The difference is coroutines has started much later, so it has the advantage of seeing how it didn't pan out really well with Rx and how Rx had to improve. And a lot of people who use Rx today also have the memory of how Rx evolved, right? And in the early days, some of that was not pretty. So people tend to not enjoy Rx as much. And they say oh, coroutines, look how nice it is. It's well thought out. Yeah, it is, absolutely, because there's also some work that's been done. But that being said, I really liked how you put it, right? If you have RxJava, then go ahead and use it. But if people are starting from scratch, there's zero knowledge in Rx, zero knowledge in coroutines, then coroutines sounds like something that would be very interesting to sort of adopt, I guess. Anything? Sorry, yeah. I know one of you guys had something to say and may have cut you off. Anything else you want to add to that?
All good.
Cool. So coroutines is better than RxJava. That's basically what Sean and Manuel said. Okay, next
question. All right. We do have a couple questions left here, and then we'll let you guys get going here. Are there any coroutine gotchas that we should know about that maybe we haven't talked about so far?
I would say like when you first start adopting the new technology, we said that Coroutines has kind of a lower learning curve that RxJava can have, right? But there are a few things that you have to keep in mind. First is testing, and the second one is how errors and cancellation are propagated. So having learn from resources available on the internet, it's pretty important, because if you start like doing things without actually thinking about them, you might probably like shoot yourself in the foot. And so document yourself, trying to understand everything involved there, like particularly about testing and error propagation, because there are some gotchas that might hit you in the future if you are not aware of what's going on.
Okay. Good to know.
That's good. Yeah. And following up on that, Coroutines is definitely new, and I know you guys have done some really good work. So what are some resources? Say I'm trying to start on Coroutines, right? What are some good resources I can sort of start to follow to get a better sense? And that I know you guys wouldn't necessarily want to like surface it, but I would encourage you to. Can you also talk about, because you've been doing some great work on this, can you also talk about some of that resources like that any developers listening can start to follow up on to get better at Coroutines?
So two things I really want to mention here. If you're getting started with Coroutines, we put together these code labs that are pretty good resources for kind of like a longer form introduction to coroutines with a very Android focus. So both code labs take an Android app and add various features of coroutines to it. So the first one is this using coroutines in your Android app code lab, and it takes you through this case we were talking about earlier, where you just want to make a network request from a view model, and it talks about all of the code transformations you'll do in order to do that. And then we recently launched an advanced coroutines code lab, which takes a look at the Flow APIs and tries to build kind of a streaming Android app using the Flow APIs. And it solves that very common use case we all have to do, where we have a recycler view, it has some data in it, and we need to restream the data to that as the database changes. So that's those are the two big resources I would definitely mention. And then for testing, Manuel and I had a talk at ADS. Then there's also, I don't know, I think, Manuel, you're talking at CotlinConf. Do you want to talk about that real quick?
Yeah, so about cancellation and error handling, I talked with Florina at also CotlinConf this year. So fully recommend watching that. And actually, Sean has a pretty good coroutine series. I think it's right now 3 blog post series, which is actually pretty nice. It's a very complete explanation of how coroutines work, what you can do with them, and definitely recommend checking that out.
Awesome.
And more specifically to Flow, recently wrote a blog post about how we integrated Flow into the Android Developer Summit application and all the learnings we got from that. So we'll add that to the show notes.
Oh. Perfect. We'll make sure to also like follow up and add a lot of that stuff that you guys mentioned. That'll be super helpful. We also have like some other resources. Like I've thrown in some of the stuff that we've talked about in the episode, like, some of the CotlinConf talks that I've seen before. I know, Sean, you mentioned Chris Baines, like the animation stuff. We'll make sure we add some of that in the show notes. That, I guess, covers a whole bunch of this stuff.
Yeah, it was action-packed, man. Thanks, you guys.
Yeah, I know. I mean, 60 minutes in, and I feel like, we've like every bit of it was, there's like dense content there. Anything else before we start to wind off, Sean or Manuel? Any parting thoughts on coroutines?
I think that's it. Thank you very much for having us in the show. We really appreciate that.
No, it's our pleasure. And if folks want to reach out to you, because you've been doing some great stuff on coroutines, how do we reach out to you? Sean, is there like a good way we can reach out to you?
Yeah, the best way to reach me is on Twitter. You can reach me at objcode, OBJCODE, which, to clarify, because I'm on audio, is object code, not Objective-C code.
Not Objective-C code.
Sure.
I wonder why you found the need to like make that so explicit, Sean. But oh well.
Guilty conscience.
Manuel, what about you?
Same. Twitter would be probably the best place to reach me. It's Manuel Vicnt. So I'll be there.
Perfect. And we'll make awesome. Yeah, and we'll add that in the show notes too, so folks can get the spelling right. Donn, if folks want to find out what's happening in your life, Coroutines, and the other backend stuff that you've been experimenting on, what's a good place to do that?
You can either follow me on Twitter or Instagram, same handle, which is Donn Felker. And Kaushik, what if folks want to see you and hear about your glorious travel days? How can I find you?
Oh my God, boy, do I have a story to tell. Kaushik Gopal is my username. You can find me again on Instagram and Twitter with that handle. Thank you all so much for listening. Sean and Manuel, thank you so much for coming on the show.
Thank you.
And helping us understand this and sharing all the knowledge that you have. Thank you so much for joining us.
Thank you. Our pleasure.
Thanks for having us.
Thank you all so much for listening, and we will catch you in the next episode. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.